Hey guys, welcome back to the channel. My name is Dishu and you're watching Data Science with Dishu. So in the first session we have seen what is actually libraries and modules. Then we have started with the introduction of libraries, that is NumPy, and then we have seen what is NumPy, why we use NumPy, how to import NumPy library, what are the different ways of creating the NumPy array. Then we have seen NumPy arrays, a class that comes under NumPy. So we have seen how we can create NumPy arrays, what are the difference between arrays and list, like how an array has more advantage as compared to list. Then we have also seen some of the attributes of array. Now in this session we are going to start with slicing of arrays. So slicing concept you have already seen in list and string, how we can slice the part of list or string. In the same way we can also slice some of the elements that are coming under an array. So since an array has n dimensional, so it can be one dimensional, two dimensional or three dimensional. So the way of slicing arrays in 1D or 2D or 3D arrays are different. So you can either extract a single element, that means slicing a single element out of an array, or you can slice a part of array from the array. So before starting this session, check out the two previous sessions there and make sure you like this video so that it can reach to the more people like you. So let's start with slicing 1D arrays. So as you have seen, while slicing a list or a string, you have to give a square bracket, and inside that you have to get the starting and ending index to slice a part of that list or string. In the similar fashion, you have to give a starting and ending index for an slicing of array. Now here we are going to slice a 1D array. So you can see here, this is your data, that means a name of the variable or the 1D array. So we have 1 2 3, those are the elements of that array. Now you can see this is a 1D array since you have only rows and the single column. Now as you have seen the indexing part in list and string, as it start with 0, in the similar fashion it start in array also, it starts with 0. So the first row we are having 0th row, and the second row is called first and the third row is called second. In the similar fashion it goes on. Similarly it happens for the column also, but since here is only a single column, since it is a 1D array, you don't need to give the indexing for column. So let's say you want to extract an element of that array. Let's say you want to extract 1. Since this element 1 is present at 0th row and the 0th column, since it is a 1D array, you don't need to provide a column index. So just providing the row index, since it is the first row, you have to just give data square bracket and 0, so it will just extract 1. Similarly if you give data 1, so at the first row you have 2. Similarly if you give data square bracket 2, it will extract 3. Now these two are example of slicing a single element. Let's say you want to slice more than one element. So let's say you want to slice 1 and 2 together. Now to slice 1 and 2 together, you have to give a starting and ending index. So you can see data 0 colon 2. That means you have to start with 0 and you can go up to 1 only, since 2 is excluded. So 0 and then 1. So it will extract 1 and 2. In a similar fashion, if you want to extract 2 and 3, so you should start with 1 and you should go up to 2. That means at the last index you have to give either 3, or if you don't provide any index, so it will go up to the last, since the last element is only 3, so it will get 2 and 3 together. So this was about slicing and part of array that is continuous element. If you want to give a step size, that you can also provide. So you can see a start, end and then a step size. So that you have already seen. In the same way it will happen as it happens in the string and list. So let us see some examples so that it will become more clear. So let's say I'm defining an array ARR, and that is np.arrange. So using that arrange function, what I'm doing, np.arrange 10, that means continuous element from 0 up to 9. I have to create a 1D array. So it will create a 1D array, and you can see this is the 1D array we have. Now if I just give ARR 6, so that means I'm slicing a single element. So what will happen at the 6th index, which element is there? So since it start with 0, so 0 1 2 3 4 5 6, so since the elements are same as the index, so it will just extract 6. So if I just run that, it will print the 6th element, that is 6. Now let's say I want to slice elements from 4th index up to the 7th index. So I will provide 8 so that it will go up to 7. So it will just extract 4, 5, 6, 7. So you can see if I just run that, it will extract 4, 5, 6, 7. Let's say I'm creating another array with the same name. That means it will override the previous array, and the function that I'm using is the np.random.random. So it will just create a that size of the array will be 10. That means 1D array, and the elements will be randomly chosen. So it will be just float random numbers. So you can see 0.32, 0.41 like that. So it has created an array ARR. And let's say I want to slice an element with the step size. So instead of just slicing from 2 to 8, I'm providing the third value after the column. That means I'm giving a step size of 2. So it will just escape the one element and it will take the second element. So after this element, it will take this element, and then after that this element, like that. So let's say I want to slice between 2 to 8 with the step size of 2. So you can see 0, 1, 2. So this is the first element it will be taking. So you can see this one is taking, then this it will escape, and this it will take 0.31. So you can see this one, and after escaping this one, it will take this one. So you can see 0.83. Since this is at the which index, 0, 1, 2, 3, 4, 5, 6, 7. So that means this is the last index it can go up to. So that is why it will stop here. Now let's say what happen if you don't give the starting and ending index. So if you don't give any starting and index, so by default it take a starting as a 0, and by default it take ending index at the last index. So if you don't give any starting and ending index, and if you just give the step size of 3, it will start from here. So you can see if I just run that, it will start from here, then taking the third element, that means this one, then again taking this one, and then it will take this last one. So you can see these are the elements that it is returning. So I hope that is quite clear. That is the easy thing, and you can play with that with many different type of slicing, and you can learn by yourself. Let's move towards the slicing 2D arrays. Now it is just the same thing, slicing, only the difference is that instead of having a single column, you are having multiple column here. So instead of having just more than one rows, you are having more than one column also. So indexing will start at the rows also, and indexing will start with the column also. So you can see it will start from here. This row indexing you already know, and column indexing start with here. So 0, 1, and if there are more columns, it will go on. So let's say you want to this element 2. So 2 is where? At the 0th row and the first column. So here you have to provide two values here. So instead of having one value inside that square bracket, you have to provide two values with the help of comma. So you can see that the first value is the row value. That means you want at the 0th row, and after comma you are providing 1. That means you mean first column. So you need to find out that where these two are intersecting. So this is the 0th row and this is the first column, so it is intersecting here. That is why it is extracting the second element, that means 2. Now what if I don't give the second value? That means after comma, that means I'm not giving even comma. So I'm just giving data 1 column 3. So if it is a 2D array, and if you don't provide any value after comma, that means the second value, it will take all the columns. So if you just give the first value, that means 1 column 3. So this is for what? This is for just rows. So it says that it should go from first row up to the second row, since 3 is excluded. So it will take first and the second row. Now what about columns? Since you have not given any value, it will take all the columns. Since here are only 2 columns, it will take only 2 columns, and these are the elements that it will extract. Now in the third example, you can see I'm slicing a part of array with the help of both values like rows and columns. So you can see I'm providing from 0 to the first row. So 0, first row, these are the rows it should take, but it should take only the 0th column. So the second value is a 0th column. So it should take only this element, not this one, because I am providing the value of column 0. So that is why it will take 0 in the first row and the 0th column. This means this is the element it will extract. So this is how you can slice a 2D array also. it's quite simple. So just as extra value that you are adding for the column value. So in the 1D array you are providing just for rows, and in 2D array you are providing for column also. Similarly, if you go for the 3D, it will be having another value, that means at the third dimension. So let's quickly look at some of the examples. So I'm creating a 2D array, and after that I'm slicing elements, that means 1 comma 2. So 1 is the first row, and second value after comma is the value of the column, that means second column. So the first row is which one? If you print just the 2D array, you can see this one is the array we have, and the first row is actually this one, not the first one, like indexing start with 0 no. So the first row is this one, and the second column, so 0 1 2. So this is the element, since it will intersect here, first row and the second column. So you can see 6 is the element it will return. Similarly, if I do another 2D array with the elements 1 2 3 4 5 6 and 7 8 9, and you can see I'm just slicing some of the part of the array. So from 0 to 2, so it will take just rows value, so 0 this whole row, and 1 this whole row, and since it will not go for a 2, so 1 2 3 4 5 6, that it will return. So you can see this is the value it is printing. So this is the array that we have defined. This is the result of the first slicing we have done, and the second slicing is what? The same slicing, but I am providing another column value also, that means from -2 up to the last. Now you can see you can give slicing value in negative also. So you already know that slicing with negative value means it will start from back. So if you give -2 column, so it will start from last column. So you can see in here in 2D matrix, this is the last column, so this is the -1 and this is the -2. So it says it should start with -2, but it will go up to what, like ending index is not provided, so that means the last index. So it will go for the this column also, so that means this both column it is taking, this both column, but rows are only first 2 rows. So you can see it will return 2 3 and 5 6 only. So that is why it is returned 2 3 5 6. So it is just an easy thing, but just you need to concentrate on the thing that which element you are slicing, what are the step size that you are giving, what are the indexing that you are giving. So you just need to focus on those parts. So it might happen that you will do a slight mistake, but the concept wise it is totally like very easy concept. And let's say if you want to get the first column, how you can get that? First column is what, all the rows you want, but only the 0th column. So that is why for the rows I have given no any starting and no any ending index, so it will take all the rows, and I have just provided 0 on the column value, that means it will take the first column only. So you can see 147. So this is the value it is returning. Cool. So that was about 2D array. Similarly 3D array, as I said, there will be another third value that will be adding here. So if I just create a 3D array here, and if I want to keep the slicing, like you can give the first slicing element, the second value, and the third value. So third value is the in the third dimension. Now this might be tricky, that you will be confused which is the third direction actually. It's like 2D के लिए तो easy है, like first is the row and the second is the column, but for 3D it might be confusing sometime कि third dimension कौन सा है, like first is the row and there is another 2 column you have, so it might be which one is the second direction and which is the third direction. So it might be confusing sometime. So what you can do, you can just provide the element and check which are the element that it is extracting, and based on that you can know that the second value is for which direction and the third value is for which direction. So if I just give a quick example, you can see this is a 3D array that we have created. Now focus on this last one. So if this will be cleared, all the things will be cleared. So you can see the first slicing value is what, from 0 to 2. So the first value of slicing is what, 0 to 2. So since this is a 3D array, so first you have to take that outer bracket, and inside that you can see there are 3 2D matrix we have. So you have to go from 0 to 1, 0 to 1 actually, yes, 2 is excluded. So this is actually total, that is 0, and this is 1. So you just ignore this one since it is already excluded in the first slicing part. Now the second is what? In the second direction you have to take from 1 to like no ending index. So that means up to the last column. So you can see after that square bracket, that outer, you have to come to the inner square bracket. So this one, that means second one. So that means you have to go for this 2D matrices. So there are two 2D matrices you have, and now you have to take the rows from 1 to the last row. So that means this is the 0th row, so this is the first row, and this is the second row, that means the last row. So this one, and again from this 2D matrix also this one. So these are the two part that are extracting here. Okay, now in the third value, again you are taking from first column up to the last. So in the third one you have to take from this direction. So this is the 0th column, and this is the first column. So you have to start from the first column and you have to go up to the last column, since there are only two columns. So after 0, this is the first one. So 2, 4, 6, 8, 10, 11. So this is the two column that you are extracting here. Now again remember from the first thing, you taken this one, then after that you have taken this one and this one, and at the last you have taken this column only. Now if you just intersect all the part, you will get that the only element are 4, 6, and here 10, 12. So that is the element you are getting here. You can see 4, 6, and 10, 12. So I know it might look some tricky, but it is very easy thing. Like I will suggest that you should do more indexing on that thing, and you can observe each of the indexing, that how it is doing that indexing, sorry, I'm telling that slicing actually. So how that slicing is working for each of the elements, and that's how you will understand that how it is working. So next we are going to look at the array manipulation. So what is that meaning? Array manipulation. So manipulation means you are doing some changes on that means whatever the array that you have, or the original array, you are making some changes on that array. And how you can do that? So there are many methods using that you can do that. That means the first one is the np dot transpose. So for any array you can make a transpose. So if you know about transpose, that will be quite clear, but if you don't know, I will just explain that thing. Then you can use dot reshape. So I have already shown you that dot reshape used to reshape the size of the array. And then there is also a resize. So also I will tell you what is the difference between reshape and resize. Then there is np dot flatten, that means to flatten the array. So whatever the dimension of array it is, if you use np dot flatten, it will just convert that into 1D array. So let's first start with np dot transpose. So if you don't know about transpose, what is happening here? Transpose simply means that whatever the rows you have, that will be converted into column, and whatever the columns you have, that will be converted into rows. So that means, let's say this is the data we have, that means this is the array we have, and since you can see how many rows it has, 1, 2, and 3 rows, and how many columns it has, 1, 2. So 3 rows, 2 columns. So after doing transpose, what will happen? These rows will be converted into columns. So that means the first row is having element what? 1 and 2. Now you can see here the first column will be having element 1 and 2. The second row is having the elements 3 and 4. That means the second column will be having element 3 and 4. Similarly 5 and 6 and 5 and 6. So here it was having 3 rows, 2 columns. Now it is having 2 rows and 3 columns. So that means it is just reversed. So that is what a transpose is about. And you can see this is the way of denoting a transpose. So let's say A is a matrix and you want to find out the transpose of A matrix. So this is how it can be denoted. Let us use it, how we can use np dot transpose. So let's say I'm creating a 2D array. Okay, so using that dot random dot randint, that means every element will be integer and the range will be from 1 to 20 and the size of the array will be 6, 2. So this is the array that we have created. Now what we are doing, the shape of the array that we are checking. So the shape of the array, how we can check? Using dot shape. So using that dot shape attribute, you can see this is the shape of the array that we have, since we have provided the same shape to create the array. So that is why it is returning that shape. Now let's say I want to transpose that matrix. So how we can do that? Simply, this is the syntax np dot transpose. So let's say I'm giving another name to the transpose matrix. So let's say I'm giving array underscore transpose, and then this is the syntax we have, array np dot transpose, and then the array that we have. So initial array was array 2d, and we want to transpose that array. So that is why I'm providing that array. And now if I just print that, so the transpose array is looking like that. So you can see every rows are getting converted into columns. So 6 12 6 12 10 17 10 17. So that is how. And if I just check the shape of that array, you can see 2 6. So it is just got reverse. So instead of 6 2, it is having 2 6. So this is how you can use np dot transpose to transpose a matrix. Next we are going to look at the reshape. So dot reshape, it is used to get a new shape to an array without changing its data. So what does that mean? That means, let's say this is the data we have. So this is what a 1D array we have. So the shape of the array will be 6 1. Now if you want to reshape that, so as I've already told you that after reshaping, the multiplication of the shape of the array should be same as the initial. So 6 1, that means 6 into 1 is 6. So you can reshape that into either 2 3 or 3 2, because the multiplication will be same. So you can see if I just reshape that into 2 3, what will be the result? So this is the result we have. So the first 3 elements are coming here, and the last 3 elements are coming here. Similarly, if I do 3 2, so that means the first 2 elements here, then the second 2 elements 3 and 4 here, and then 5 6. So the shape up will be, this array will be 3 2. So this is how you can just reshape the array. So let us look at some live examples. So let's say again I'm creating a 2D array with the elements between 1 and 20, and this is the shape that we are using. Now the shape of the array is 6 2. Now the multiplication of the shape of the array is what? 6 2, that means 12. So now if I just want to reshape that, what are the shape that I can do? Either if I want to convert that into 1D array, I can do 12 into 1. So the multiplication will be 12. Then we can do 3 4 also. We can do 4 3 also. And what else? Nothing, I think. Yeah. So there are only 3 options to reshape that array, either into 1D array of 12 1, or a 2D array of 3 4, or 4 3. So let's say I want to reshape that into a array of 3 4. So you can see if I just use array 2D, that was the original array, and on that I have to just use dot reshape, and then the shape of the array that I want to change. So if I just print that after reshaping, this is the element we have. So this was the original array, and this is the reshaped array. Let's take an example of reshaping the array with the shape of 3 5. So as you already know that the multiplication of the shape is here 3 5, that means 15. That is not the exactly same as the initial array. That means 6 2 is 12, not equals to 15. So it will just not change that the shape of that array. It will say cannot reshape an array of size 12 into 3 5. Now let us look at another way of resizing the array, that is having np dot resizing. Now you can see, first of all, the difference is that, so this np dot resize is an in place operation, but this dot reshape was actually not in place operation. So you have to reassign the variable to make sure that it changes in the original array. Now let's say I'm creating a 3D array of size 2 3 5, and this is the array that I have created, and the same is this one. Now let's say I want to change the shape of the array, and I want to resize that. And what is the syntax that I'm using? np dot resize, and this is the original array that I'm providing, and then I'm providing another value, that is new shape. So the new shape of the array that you want to change So let's say I want to change into 5 comma 2 comma 3. So since the multiplication will be same, it will be got changed here. So you can see this is the new resized array. So since the multiplication of the new array, shape of the array, and the old one is same, so it will just change that. So this is the new resized array, you can see. Now let's say I'm trying to change the shape of the array with the value that is that means the multiplication is not same. So 5 comma 2 comma 4 is actually 40, but it is not equal to this one 5 comma 2 comma 3 that is having 30. So let's say what happens. Let's check if it can change the shape of the array. Oh, it's just changed. So how it is happening? So this is one more advantage of dot resize function. So if you use dot reshape, you cannot do that, but using dot np dot resize you can do that. Why it is happening? Like you can see, I've already introduced the concept of size. So size of an array is what? How many elements it has. So instead of changing the shape, you are changing the size of the array. So if you are changing the size of the array, it can actually introduce new elements. Like not new elements, it can change the size of the array. That means instead of having 30 elements, you can change into 40 elements, but there will be no extra element that will be introduced here. Just from the previous one, whatever the original array you have, it will start repeating those elements. So you can see, I can just show you. Let's say if I am just running that, what are the elements it has? 7 3 15 16 7 8 7 6. Okay, now what was the size of the original array? 5 into 2 into 3, that means total 30 elements. So up to where 30 elements are coming here, you can see these are 8 elements, then 16, then 24, then this one up to here 28, and this one 30. So up to here these are the elements that are from the original array. That means it was starting from 7, and it was ending up to 15 12 16. So you can see 15 12 16, it is ending here. But since the new shape of the array is what? 5 comma 2 comma 4, it needs to introduce extra 10 elements to complete that shape. Now how it can do that? It can just repeat the elements. It will start from here again, 7 3 15 16. That means from the original array actually, 7 3 15 16. You can see, you can observe that after that you can see 7 3, then again 15 16, 7 8 7 6 10 10. So you can see after here it is just starting repeating these elements, 7 3 15 16, 7 8 7 6 10 10. So this is the element that it is repeating here. So this is the beauty of dot resize method. So using that dot resize method, you can just change the shape of the array to any shape that you want. It will just repeat the elements, and it will take the repeated elements from the original array, and it can make up to whatever the shape that you want. So if you want to create that into a 1D array, you can just provide 30 elements. So 30 elements are actually the original elements you have. Let's say you want to create the 1D array of 50 elements. If I just run that, it can create 50 elements. It will just start repeating that from here to here. You can see this is the one time it is, then again from here to here it is repeating, and it is going up to 18 only. That means up to here it is repeating. So I hope you got that. Next is the np dot flatten. So as the name suggests, dot flatten, that means is just flat the array. That means it will convert into a 1D array. So let's say you have a 3D array like that. If you just use dot flatten onto that array, whatever the array you have, it will just create a 1D array. That's the simple thing that you can do using that np dot flatten. Cool. So I am stopping it here. I thought कि मैं 3 लेक्चर में कंप्लीट कर देता NumPy ट्यूटोरियल, बट इट रिक्वायर्स वन मोर सेशन टू कंप्लीट इट. सो वीडियो का लेंथ मैं ज़्यादा बड़ा नहीं करना चाहता, दैट इज़ वाई आई एम स्टॉपिंग इट हियर. Cool. So I hope you got everything whatever I have taught today, and if you have any doubt, feel free to ask the doubt on comment box, or you can ask the doubt into the WhatsApp community. Just check out the description and join the community there. So cool, we'll meet in the next session. Till then, take care, goodbye.